Okay, in this video we're going to be talking about matrix multiplication. And the two concepts we're going to be talking about is scalar multiplication and then a matrix times another matrix. So let's go and get started. The scalar multiplication is actually pretty simple. And I have an example of this one right here in red, where if you have a matrix, which the matrix itself was a 2 by 3, the 11.25, 11.96, this matrix here, and it's being multiplied by this 4. Well, very simply, if you're just going to multiply it by just a whole number, a scalar, then you would multiply the 4 to every single element inside of the matrix to get an answer of this down here. Now, sometimes using decimals can be kind of confusing for students, so let me really quickly just kind of draw or create a matrix. So if I had a 2 by 2 matrix, and we'll just call this, let's say 2, 4, 6, and 8. And I wanted to perform scalar multiplication by multiplying by a 3 on the outside. Then my answer would be, very simply, 3 times 2, which would be 6. Over here would be 12. This would be 18. And lastly, this would be 24. And that would be my answer. All right, so let's go into something that could be a little more challenging, and that is matrix times another matrix. And now, as we go through these slides, you might actually have to pause the video just to take some notes for anything that you might need. All right, so let's go and get started. Multiplying matrix by another matrix. Now, what you're going to do is this. Each matrix has its own dimension. And the dimensions are actually very important. So I went to a blank slide. So I'm just going to do a very simple 2 by 2 matrix. So let's just say that's 2, 3, 4, and 5. And I'm going to multiply it. I'm just going to put a dot for multiplication. Times 6, 7, 8, and 9. Okay. Now the dimensions of this, of these matrices, let's see, this is a 2 row by 2 column matrix, and this right here is a 2 row by 2 column matrix. Notice here how the numbers on the inside, this 2 and 2, match. Okay, that's very important because if they do not match, you cannot multiply those matrices. So like for example, if we had a matrix that was a 2 by 3 and then another one that was a 2 by 2, notice that the two middle numbers do not match, so you will not be able to multiply those matrices. All right. Now the outside numbers are actually very important too because of the fact that these numbers here, which I'm going to highlight in green, represent the dimensions of your answer. Okay, so that means our answer will be a 2 by 2 matrix. Okay, now that's actually very important because it helps you with the next step. So I know that my next or my answer will be a 2 by 2 matrix. This is a step that I like to use just to kind of help students see this. I know that my answer is going to be a 2 by 2 matrix, so I'm going to go ahead and put in all the blanks here. Okay. Now my answer will actually be down here. Okay, this is my answer that will be down here. All right, now this matrix here is what I call a location matrix. And this location matrix is probably going to seem a little silly once you get used to it, but when you're learning how to do this, is actually very important. This would be row 1, column 1. This right here would be row 1, column 2. I'm just naming the locations of each element. This would be row 2, column 1. And lastly, this would be row 2, column 2. Okay? Now, the reason we do this is because we're going to go back into the original problem, and I'm going to label my first matrix here. This is my row matrix. My second matrix over here is what is called my column matrix. Okay? Now, the reason I'm doing that is because your little location matrix that you started or that you created will help you start multiplying through your matrices. And let me show you how. Notice if we're going to solve for this blank right here that I'm just highlighting in blue, if we're going to solve for that, we know based upon our location matrix that is a row 1, column 1 matrix. So with our row matrix, we're going to start with row 1, which is right here at this 2. Now, for a column matrix, you always think down. You're going to start with column 1, which is 6. So the first thing you're going to do is you're going to multiply 2 times 6. And so when you do that, you get 12. And then you move over to the 3 as you move down to the 8, and you multiply that again. And that's 3 times 8, which gives you 24. And of course, you would add that. So I guess I should have made actually another final matrix here. So that means let me put the blanks again just so I keep everything organized. So my answer here would be 36. All right, let's try another one. You have this one right here, which is row 1, column 2. Well, I'm still going to be dealing with my row 1, so I'm going to keep that 2 underlined. But rather than going to the 6 for column 1, I'm going to be going over to the 7, which is column 2. Notice row 1, column 2. This is row 1, but this is column 2 on the other matrix. So 2 times 7, which gives us 14. And I'm going to move over to the 3 as I move down to the 9. 3 times 9, which is 27. I'm going to add those two. So when I add all that information together, I should get 41. All right. So let's go down to our next problem, which would be, or our next blank, which would be row 2, column 1, which would be this one right here I'm underlining. So now row 2, I'm going to, that was too big. Let me make that eraser a little smaller. So now I'm going to go to row 2, which row 2 is right here, column 1. I go back up to the 6. 4 times 6, which gives us 24. And I'm going to move over to the 5 as I move down to the 8. 5 times 8, which is 40. So when I do that math, it becomes 64. All right. And lastly, and lastly, my final, which is this one right here, my final entry, is going to be a row 2, column 2. So I'm going to start with 4, and then I'm also going to start with 7 here. So 4 times 7, that gives us 28. I'm going to move over to the 5, move down to the 9, which gives us 45. Now I'm going to do a quick math here. I believe that is going to be 73. So that's how you do it. Okay, for my next problem, I'm going to use something that doesn't have matching dimensions per se. So this matrix here is a 3 by 2 matrix, 3 rows, 2 columns. This matrix here is a 2 by 2 matrix. So once again, my two middle numbers match, and so that means my dimensions of my answer will be a 3 by 2. So what I'm going to go ahead and do is write a location matrix to kind of help me with with what will be my answer. Okay, so there is my working matrix as well as my kind of like my work matrix, so to speak. All right, so let's go and get started with this problem right here, or that entry. Notice that is row 1, column 1. So once again, I'm going to start with row 1, and then I'm also going to start with column 1. So I'm going to take 3 times 1, which gives us 3. And then I'm going to move over to the 4 as I move down to the 3, which gives us 12. And you would add that together to get 15. Now, to save time, I'm not going to add them together. So you can do that on your own. All right, so next, let's go ahead and just work with row 2, column 1. So if it's row 2, column 1, once again, excuse me, I'm going to, let me erase that, start with column 2, but stay with column 1. So that's 5 times 1, which gives us 5. And I'm going to move over to the 6 as I move down to the 3, which gives us 18. And as I continue working down my first column of my answer, I'm going, or my first column of my answer, I'm going to now work on that one, which is row 3, column 1, which means I'm going to start with row 7. Or I'm sorry, which is the 7 to start with the 1, which gives us 7. And I'm going to move to the 8 as I move down to the 3, which gives us 24. And I'm going to go ahead and stop the video. You keep working, and then you see if you get the right answer. All right, so I went ahead and solved for everything, and so my final answer would be this down here, the 15, 22, 23 matrix there. And if you have any questions, let me know. Thank you.